Crewton Ramone's Completely Cool Curious Counters Compendium. So let's get started and go through this page by page. Basically, we start off with this is 1. If it's no fun, get back to 1. 1 and 1 make 2. A very simple thing to do. So you can start seeing right off, starting right out of the gate, we start talking about, let's do problem solving and understand. Well, all this means is we don't know what the other one, what does it have to be to make 2? We'll start very simply with little kids. 2 ones are the same as 2. So now we get into the concept of same and equal, what that means. Same is equal, that is true. Here is the symbol for and when it's math, we use the plus sign, not the ampersand. So 1 and 1, 2. Could you hold up one finger in each hand? That's 1 and 1. You get 2. 2 plus 1, and that's a sum. And 2 plus 1 are the same as 3. 2 plus x is 3, x plus 1. X plus 1 equals 3, so x must be 2. So if 2 plus what would be the same thing as 3? Any little kid can see that. X plus 1, any little kid can see that it must be 2. So what are we talking about here? We're talking about this or this, depending on what the x is, depending on what the symbol is. Now it's time to count with me. 1, 2, 3. Count with me. It's so easy. 3 and 1 make 4. X is a variable, and that means change, and the way we find out what x is by finding same. Look at 3, and you can see finding x is super easy. So again, if I know that 3 plus 1 is the same thing as a 4, and it's very easy to see, then 3 plus what is the same thing as a 4? Well, there you go. And something plus 1 is the same thing as a 4. Well, the something must be the 3. Logic and reasoning. Start off easy with little kids. 2 and 2 make 4. There's only 2 combinations. There are no more. 3 and 1 and 2 and 2. That's it. And again, go through and play a little bit with blocks, but if it's bedtime, you're just reading the story. Some get confused by this thing called x, and they think it's an algebra monster like T-Rex. But x can be any number. The equal sign tells it to be. For example, in x plus 1 equals 4, the x is 3. And little kids like building this T-Rex, I found out. So let them. It's fun to play math and fool around with blocks and keep it simple, even for little 5 and 6-year-olds. Actually, you can go, this book was designed for children under the age of 5. 1 and 3 is the same as 2 and 2. Easy peasy for you to do. And they can see it very clearly there. 1, 2, 3, 4. We're not done. Let's do some more. 4 and 1 is the same as 5. Now we're building 5s, and they can see that definitely a 4 and a 1 is exactly the same thing as a 5. No mystery there. And that if I have 4 plus x is 5, then x must be 1. If I have x plus 1 is 5, the x must be 4. And they can see it. They can play with the blocks. You can see he's getting more and more hair as we go along. We can build 5 with a 4 and a 1, or a 3 and a 2. Just stick them together. That's all you do. 1 and 4 and 2 and 3 are the same as 5. And there's your combinations for 5, as you can see. 5 and 0, 4 and 1, and 3 and 2. And then we just, same thing, play with 5s and fool around and figure out, well, if 4 plus something is 5, then there it is. We can see that here is 4 plus x is 5. Well, it's the same thing on each side. It just looks different when I have the blocks. When I have the symbols, I can start discovering x must be 1, x must be 2, x must be 3, x must be 4. And if I put them in order like this, it's easy and simple for the child to understand that as this number comes down, this number goes up, right? So 1, 2, 3, 4 here. And that all we're doing is putting them together, all the combinations for 5. Finding same is kind of fun, just the same. Just find the same in the other one. Can you see their same on either side? And one of them is just trying to hide. That's all it is. Because they're same. It's the same thing. as long as we know, in this case, for example, that x is 2. So 1, 2, 3, 4, 5. Now the numbers come alive. What's the next number in our mix? After 5, next comes 6. We can make 6 with 5 and 1, 4 and 2, 3 and 3. It's as easy as can be. They're all the same. It's not complicated. It's really quite tame. 5 and 1, 4 and 2, 3 and 3. There it is, spelled out. And your kids can build them, point to them. If you're on a tablet or if you've got it printed out. Numbers are made of other numbers. Remember this when you slumber. 6 plus 0, 5 plus 1, 4 plus 2, 3 plus 3. Finding out if it's odd or even. Finding out if it's odd or even. 1 is odd. 2 is even. 3 is odd. 4 is even. 5 is odd. 6 is even. It's really easy when you can see them. 1, 2, 3, 4, 5, 6. Numbers are simple. They don't play tricks. Practice finding x again. We call this problem solving. Problem solving is easy and fun. I'm sure you'll find the other ones. So here we just give them a chance to figure out, well, what does it have to be to make the 6? And notice the degree of difficulty here. So 5 and 1. It's visually obvious if you put a 6 block here, and I didn't want to do it because it would be too busy. But if you put a 6 block here and you put a 5 there, it's visually obvious that it's the 1. Same thing if you put a 6 block here and you put a 4 there, it's visually obvious that it's a 2, and so on. Anyway, 6 and 1 make 7. 5 and 2 make 7. 4 and 3 make 7. Practice those so there's no forgetting. They should know these off the top. I mean, not even have to think about it. If I ask them what 4 and 3 is, they shouldn't have to think or pause or look at their fingers. And this book will help you make it that way if you read it to them over and over again. The same way you read Cat in the Hat 1,000 times, the same way you read Green Eggs and Ham 1,000 times, and the same way you read Goodnight Moon 1,000 times. To read this to them 1,000 times, they will have math facts in addition to some number fun here, being able to write their numbers and identify their numbers 1, 2, 3, 4, 5, 6 when they're written. But more important than that is to be able to see that 4 and 3 are 7. You can do math around the clock. 6 and 1, 5 and 2, 4 and 3. But there's only 3 ways to make 7 with 2 blocks. Right? Those are your add-ins. There are 3 combinations for 7. You can build a 7's wall, build it flat, or build it tall. Sammy has a 7-ton truck. Sammy has 5 tons loaded. What block is going to fit right there? It's so easy peasy. It's not fair. So a 5 needs a 2 to make a 7. And it's very easy to see. Like I said, you put the blocks on top of each other, and it becomes visually obvious, and they can't miss it. So there's all your combinations for 7. But there's only 3 combinations when you get right down to it, because these 3 are the same as those 3. 1, 2, 3, 4, 5, 6, 7. Now we've got our brains a revving. X plus 4 equals 7. What has to go there? Any little can see what it is. 2 plus X equals 7. What has to go there? See, algebra, it's easy to understand. And you can tell stories. I've got 7 cookies. I've got 7 friends coming to a party. So far I have 4 chairs set up. How many more chairs do I need to set up so all 7 kids can have a place to sit? Well, we need 3. If I have 7 and friends coming over, and so far I've made and decorated 2 of those cool cookies with icing and so forth on them, and I've made 2, but I have 7 friends coming, how many more cookies do I have to make? 7 and 1 make 8. So do 6 and 2, 5 and 3, 4 and 4. You could build these on the floor. Here are ways to make 8. There's only 4 ways. Ain't that great? 7 plus 1, 6 plus 2, 5 and 3, and 4 and 4. That's it. Those are the only ways to make 8. You can do math from March to September, but when you make 8s, there's only 4 combinations for you to remember. 1, 2, 3, 4, 5, 6, 7, 8. I can hardly wait. We're doing fine. Next, of course, we're making 9s. Now, here's the 2 that you want to emphasize, 9s and 10s. Now, you may look at this and think to yourself, there's more than 4 combinations on this 8 shelf. But actually just 7 and 1, 6 and 2, 5 and 3, 4 and 4, 3 and 5, 2 and 6, 1 and 7, and 0 and 8. But 1 plus 7 and 7 plus 1 are exactly the same. To count them twice would be inane. So saying that 7 and 1 and 8 and 1 and 7 are two different combinations is a little iffy. You can, if you want to be maniacal like that, you can, but 7 and 1 and 1 and 7 are the same thing. It's very visually obvious to any little child. Now it's time to make some 9s. 8 and 1 are equal to 9. 7 and 2 are the same as 6 and 3, and 5 and 4. Also easy, or also just as easy as can be. You'll feel fine if you make 9s. 8 and 1, 7 and 2, 6 and 3, 5 and 4. Those are the only combinations. If you look at all the other number combinations, they'll help you with your 9s times table doing multiplication. So you can see that here we have all the combinations for 9. 18, 27, 36, 45, 54, 63, 72, and 81. And you can see lessons on this. This is before I had the technology to be able to put videos into my books. But eventually I'm going to remake this book, and you'll be able to click on a video that shows you how to tell or how to show children their 9s times tables by building 9s. Anyway, so 4 ways to make 9 made you feel fine. 4 ways to make 8, that was great. 3 ways to make 7, got our math brain revving. 3 ways to make 6, no number tricks. 2 for 5, 4, and 3, super easy. 2 ones for 2, and we're about halfway through. 21 combinations from 9 to 2, just one number left to do, 10. Numbers tell how many, places tell what kind, and just to make it extra easy, it never goes past 9. If you ever get past 9, you will find what you have is one of the next kind. Let's build 10s, but before we do, let's look at the square numbers we've been through. People think this symbol is a brute, but all it means is square root. There is nothing hard. No one's trying to hide. You just make a square and count one side. So if I want the square root of 9, there's 3. And kids can see, yep, it has nothing to do with the symbol. It has everything to do with the shape. So here is a square number, here is a square number, here is a square number. And just a few. Could you make more square numbers? Could you make a square out of 4s and 5s and 6s and count those? This part says make all the sides the same. You could play the squaring game. 2 times 2 is 4, and the square root of 4 is 2. 9 is square, that's 3 by 3. All the square root stuff is so easy. Could you make a square using 4s? 4 4s is 16, and I bet it's the yellowest square you've ever seen. And you can count them right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16. And you could also start your whisper counting here. 4, 8, 12, 16, 20. All 4s do is tell you how many. Well, of course, you have to stop. 4, 8, 12, 16. But you can use this book to give all kinds of math concepts to your children. So 1, 10, and 6 more make it square, and one side is 4. Now let's make 10s. 9 and 1. 8 and 2, 7 and 3, 6 and 4, 5 and 5. Yes, 5 needs a twin if you're going to make 10. 9 plus 1 is kind of fun. Then you can do 8 plus 2. And 7 and 3 is easy as can be. Then comes 6 and 4, only one more. 5 needs a twin if he wants to be 10. Now make up your own rhymes. And now we're through because that's all the combinations you can do. But now let's look at all the math that's going to be easy for you. So practice building 9s and 10s, make the walls again and again. Study these again up close. These are the ones you'll use the most. Here's some examples just for fun. 5 plus 6 is 10 plus 1. 5 plus 5 plus 1 is 11. 10 plus 1 is 11. 9 plus 2 is 11. And that's the same thing as 9 plus 1 and 1. See, because what is a 9 1? It wants to be 10, so it takes the 1 out of that 2, and there's 1 left over. So we have 10 and 1 more. 10 and 1, we call that 11. There's 45 add-ins in all. You could build them all starting small. but I'll leave that for another day. Let's keep up this number play. When you play with numbers, big is always funner. Make up your own and have some fun. And just for giggles, try this one. 7 plus 8. See, now we've given them an algorithm so that they can figure out how to put any two numbers together. You can see, or can you see, the 7 takes the 3? And there it is laid out. Certainly. What does 7 want to be? 10. What does it need? 3. Is there a 3 in that 8? Absolutely there is. The 7 takes the 3. 5 left over. So 7 and 8 is the same thing as 10 plus 5. And we have a name for 10 plus 5. 10 plus 5 is 15. Or maybe you're part of the crew that saw the 8 take the 2. Same thing, right? We just have the 8 take the 2, and we get 15 the other way. So here it is. Either the 7 takes the 3 or the 8 takes the 2. Either way, you wind up with 10 and 5. So here's another one. 7 and 6. That makes 13. That's the 7 plus the 3, taking the 3 out of the 6, because the 7 always wants the 3. And then there's 3 left over. So that's 13, a 10 and a 3. And we could do it the other way, where we have the 3, and the 6 takes the 4 out of the 7, and then we get 13 that way. And we still get 3 plus 10. Now do a few on your own, and don't do the ones we've already shown. So 6 and 8, 14. And now we can start playing with x. Well, is 6 plus what needs to be 14? Well, can we see we need 4 and 4 more? Makes it very clear what we're doing here. Using the add-ins to do problem solving and keep it simple. Try not to do subtraction because that's no fun. We'd rather do small addition. X plus 5 is 13. Well, now that we've done all that other stuff, it should become very easy. What do we have to add to 5 to get 13? Well, I know that 13 is just 5 and 5 more and the 3, right? So I have to add 8. The 5 plus 3. It becomes very clear that if I know that this number is made up of a 5, that the other part of it has to be a 5 and a 3, or, just in one shot, an 8. Because in this case, x is the same as a 5 plus 3, and 5 plus 3 is called 8. Same thing when we do some number plus 7 is the same thing as 15. Well, is there a 7 contained in 15? Absolutely there is. The equal sign never lies. So if I know there's a 7 in the 15, that leaves 3 and 5 more. So where do we take the 7? We take it out of the 10, not use up the 5, as it were, and then use up some more. We just take it out of the 10 when we see that there is a 7 in the 10, which leaves us with a 3 and a 5, and that gives us 8. Practice this and you will see that this makes math extra easy. Again, you can make a game where all you're doing is finding same. So you could make it where you have some stuff on this side and some stuff on this side, and they have to find stuff that's same. And you could actually start off where you don't even have an x, where you just have make 15, and over here you have a 7 and an 8. So they have to build 7 and 8 to make 15. Right? So over here they'd have a 10 and a 5, and what's another way to make 10 and a 5 with 2 blocks? Well, there's not too many combinations, actually. 7 and 8, a 6 and a 9. What else could we do? I think that pretty much covers the combinations for 15. Anyway, just play with it and you'll see how easy these combinations can be. Oh look, I'm a poet and I don't know it. Sometimes I rhyme. When I converse, I speak in verse. Anyway, 1. So now let's get the concept of the kinds and the names. So here's 1, here's a 10, and here's 100. 100. You can do it all again by using 10s instead of 1s. 10s make hundreds. And then hundreds get together and make, what do they make? Thousands. Oops, here we go. Thousands. 1s want to be 10s, 10s want to be hundreds, so you can play these exact same games, except now you're just doing 10s, and you keep them even. Like, don't be adding, just 90 and 10, 80 and 20, 70 and 30, 60 and 40, etc. And then you'll be amazed, little second graders. Will that work with thousands? Right? That 10s want to be hundreds and hundreds want, so yes, absolutely. 100 plus 900 makes 1,000. 200 plus 800 makes 1,000, etc. I mean, just because it's obvious to you and me, it's not so obvious to the little kids. So play with the 1s and tens, right? Making tens, but then you also have to play making hundreds, and then you also have to play making thousands. So they get it. Oh, it's just the same thing. Numbers have two parts, that's clear. There's a big difference between one here, here, and here. If you study math, you will find the numbers tell you how many and the places tell you what kind. Hugely important concept in mathematics, place value. It took us a long time as humans to get to the point where the numbers hold the places, and then we figured out we needed 0. And anyway, should be vaguely interesting for your students to study because it's taken us a long time just to get this far. When you were little, 111 was 3, but now you know it's 111, as you can plainly see. And then this is too small, it needs to be a little bit bigger, but there it is. Look at this and see how many, right? Because here we can see 100, 110, and 1 unit. But look at this and see how many. Got to count everybody, right? So it's 2,520. It's 2,520. The 0 tells you there's no ones, and counting big is lots of fun. Now let's try with tens, hundreds, and thousands hiding. It's really easy. We're just combining. So here we can see that we've got a couple of numbers where, look, this makes more than 10, this makes more than, this makes more than units, right? Makes more than 10. This makes more than tens into hundreds, and this makes more than hundreds and into thousands. So here you have the two that you can figure out for yourself and count them up and see what you get. One takes, so we'll just go through it, right? In this one, one takes twos. one, there's a cat, as you can tell. Yep, there he is. Okay, and I'm going to leave you in just because it adds humor to the whole thing. We're almost done here. Okay, 1 takes 8 or 9 takes 1. That's 110, not too hard. It's kind of fun. Now we have 110 hiding. So what we're going to do is uncover where they're hiding. Tens, 6 tens takes 4 tens, or 7 tens takes 3 tens. See, it's the same pattern. It's just now we're talking about tens instead of units. That's 103 tens. Those are easy add-ins. Now we have 100 hiding. So and then they ask the kids, are you ever going to have more than one of the next kind when you get two numbers together, when you're just adding two numbers? If you're adding a series of numbers, you can get more than one of the next kind. But if you're just adding two numbers, you're never going to get more than one of the next kind. So you only have to count one up. If you see, automatically, if you see a number like this, you should automatically know, well, this is more than 10, so this is just going to be one more over here. This is more than 10, so this is just going to be one more over here. This is more than 10, so this is just going to be one more over here. You just keep track of those. Okay, so if I know 6 and 7, I know it's a 3, I already know, just put one more over here. And so I can actually start going this way instead of this way. But that's for another day. Anyway, where was I? Let's go back to the tens. 10. 6 tens takes 4 tens, or 7 tens takes 3 tens. That's 103 tens. Those are easy add-ins. Now we have 100 hiding. Now let's go to the hundreds. 6 hundreds takes 4 hundreds, or 8 takes the 2. Now that's 1,400. It's true. Now we have 1,000 hiding. And for the thousands, 1 plus 1 is still just 2. And these ones meant thousands. Count it all up, and we're through. 3,541. So we stick them all together. And we could just as easily look this way and see, oop, I'm going to have one extra one. 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 Right? So, well, actually, I did that one too many times. It's only 3 times. But I can see, oh, that's going to be 3,541. Not 30, because I have that extra 10. Anyway, big addition is exciting. Keep track of the numbers that are hiding, and big addition becomes exciting, or is exciting. When adding numbers, you'll never carry more than 1, which makes addition kind of fun. So here it is backing out what we did. Now, let's add some pairs in preparation for this thing we call multiplication. 2 1s, right? 1 times 2, 2. 2 2s, 4. 2 3s, 6. 2 4s, 8. 2 5s, 10. 2 6s, 12. Oh, now we get a chance to make our 6 and a 4 and 2. 2 sevens, 14, up, the 7 takes the 3, leaves a 4, 2 eights, the 8 takes a 2, leaves a 6, and of course 9 and 9, and there's all kinds of exercises you can see me do with these. 9s are fun because it's just 10 minus 1. But anyway, 9 takes the 1, and there's 8 left. You could practice those, my friend, and read this book over and over again. And see, and eventually you can start playing with 3s. And one day practice with triples instead of twins. And I hope you enjoyed this book of math and rhyme. And I thank you for your time. And that's it. I think this book is worth 20 bucks. I'm selling it for 5. If you get another book, I'm selling it for 2. You get an upsell there. Anyway, it's 50 pages. And you don't have to do it all at once. You can read part of it and then stop. Just read a few pages to your kids, these first few pages, up to like, maybe, right here in one sitting. And then we'd stop like right there where we build the 10s. And then come back to it and do these. And then pretty soon you'll be able to do them all in one sitting. And of course, once you get this one down, change the numbers and try it yourself, right? Try other problems. Once you can add 2 numbers together, you can add any 2 numbers together. That's the point of the book. But you get more than just addition facts, right? You can start giving your children concepts that go beyond addition and subtraction. They need to know what the equal sign is. They need to know about square roots. They need to know, why it is we carry numbers and place value and so forth. All of these are tremendously important concepts. And the concept that numbers are made up of other numbers, also a tremendously important concept. But just play. Once you get these basic building blocks, the higher, get it? Basic building blocks? The higher, quote unquote, higher mathematics, multiplication, subtraction, division, fractions, and so forth, percentages, all become easy because they can do these. But what I find is that so many kids, by the time they're in 3rd grade, you ask them what 3 and 4 is, they have to think about it. Ask them what 8 and 5 is, and they have to think about it. Whereas by the time they're 5 or 6, those should be things that are just simple and easy because they've had experience with it. So give your children an experience that's fun and pleasant with mathematics, not drill. Grandma could be reading this book to them. I envision that. Or mom and dad, right, at bedtime, right, where everything's quiet and calm and so on. And you're just reading a book, just a bedtime story. It just happens to be math. No tears, no fear. All right, this was Crewton Ramone's Completely Cool Curious Counters Kindergarten Compendium. Get your copy today. And check out Crewton Ramone's House of Math.com for more.